muscles pull on bones. This page will look at how that happens. So we'll just take an imaginary muscle here. Here's a muscle attaching from the humerus down to the radius. The point of attachment for a muscle to a bone is called the tendon. And ligaments connect bones to bones. So the humerus, and in this case the ulna, I have them connected with a ligament here. Both very chewy if you like to eat chicken. If you ever eat the chicken bones and the joints themselves, then you get a lot of, you might eat a ligament here or there, or a tendon. They're very chewy because of all those collagen fibers. If you're a pure steak eater, you just like to eat the muscle. Skeletal muscles move bones when they shorten or lengthen. All right, and then the muscle is attached to two different bones. Every single muscle, skeletal muscle, has to cross at least one joint, or it would just be pulling on one bone, and that's not going to do any movement. That would just hurt. So a muscle must always cross at least one joint. And in the case of, let's say your quadriceps muscles, crosses two joints, starts on your pelvis, crosses the joint between your pelvis and your humerus, and then crosses the joint between your femur and your tibia. Well, the first site of attachment is called the origin of the muscle. So this is the point of attachment that doesn't move during the contraction. So in this muscle diagram that I've given you, that's why this would be the origin, because if you look down to this picture, you can see that the lower arm bone is the one that moved, not the upper arm bone. And then all muscles have to be attached to at least two different bones, and so the second point of attachment is called the insertion. And this is the point of attachment that does move. Okay, so then when we do look down here, we see one particular kind of contraction called isotonic. I'm going to use a different color, maybe purple, for this. So the main types of contraction one is isotonic. Iso means the same, like an isosceles triangle has two sides that are the same length. Tonic means tension. And in this kind of a contraction, you have a shortening of the muscle. And that's what I've drawn in this picture. So see how the muscle shortens and bulges out a little bit. So we're very familiar with that. If you like to do curls or basically any kind of a weight machine where you're lifting in the gym, you're probably doing isotonic. But there's another important kind of contraction called an isometric contraction. Iso again means same, but in this case the muscle is not going to shorten. It's the same length throughout. So you have to think, what? Well, why would a muscle be contracting if it's not making the bone change? And the answer is stabilization. So think about if you were to do a plank position, then your muscles aren't changing length as you're doing that, but if your pecs weren't contracting, then your chest would fall to the floor. So I like to think of an isometric as no length change. But if the muscle were not actively trying to contract, then two bones might crush together or you might fall down. So you'd either fall to the floor, or maybe if you think about like if you sat against the wall and flexed your quadriceps but they're not changing length, then that would be an isometric example as well. Okay, and then a third kind of contraction, actually my favorite probably, is called eccentric, partly because I am eccentric. What does eccentric mean? It means outside of the normal circle, right? Well, this is actually a lengthening. And now you might really be wondering, well, how can a muscle be contracting as it's lengthening? So the ways that this is happening is, well, if the muscle is contracting at the same time it's stretched. Think about your calf muscle. So common places this might happen would be the calves are common to do this when you're hiking uphill. And if the muscle were not contracting, then it would rip apart. So without a contraction in this kind of a movement, tearing would occur. So it needs to hold the muscle together. Of course, if it doesn't do a good job at it, you can rip a muscle trying to do too much of an eccentric contraction. And so this might cause tearing. Another way to think about this one is maybe crushing. So crushing the two bones together if isometric contraction doesn't work right, and tearing of the muscle if eccentric doesn't work right. With isotonic, if it doesn't work right, most likely you're just going to drop the weight itself rather than rip the muscle itself or crush the muscle. There's a new kind of shoe that is popular these days. It's called a zero drop. My husband has gotten really into these. So if you imagine this is the back of the calf, a zero drop shoe is totally level with the ground, whereas most shoes, most running shoes, are more like this. So do you see how you're not level with the ground? A zero drop shoe is level with the ground. So if you start wearing these, look at how you're going to be stretching out the Achilles tendon, because if we're used to a shortened Achilles tendon, and so if you start running wearing one of these new minimal or zero drop shoes, you need to be careful because your lower calf is going to get more of an eccentric workout than it's used to, and your Achilles tendon will get stretched out more than it's used to. So it's very important to ease into minimal running, although it is something quite fun to read about, and I would encourage you to maybe do an extra credit poster on the pros and cons of barefoot running, as it's called.